Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. MeO chloride, methoxymethyl chloride, MeO-CH2Cl, is a primary alkyl chloride that undergoes SN2 reactions readily. KCN is a source of the cyanide nucleophile, CN. Moving on to the next step. Identify the substrate. MeO chloride is ClCH2OCH3, chloromethyl methyl ether. The chlorine is on a primary carbon-bearing an oxygen substituent, alpha-2 oxygen, making it highly reactive toward SN2. Moving on to the next step. Identify the reagent. KCN provides CN, a strong nucleophile, and good carbon nucleophile that attacks via carbon in SN2 reactions. And for the final step, SN2 mechanism. CN attacks the carbon bearing the Cl from the back side, displacing Cl. The product is MeO-CH2CN, methoxymethyl cyanide methoxyacetonitride. Evaluate options. Option A, ClCH2CN. This would require CN to somehow leave Cl intact, which makes no sense for an SN2 on MeO chloride. Option B, MeO-CH2CN, direct SN to substitution of Cl by CN giving methoxymethyl cyanide. This is correct. Option C, MeO-CH2CH2CN, this would require a 2-carbon chain, implying an extra CH2 was added, which is not possible in simple SN2. Option D, epoxide with 2 CN groups. No basis for epoxide formation or double cyanide addition under these conditions. The straightforward SN to substitution of Cl by Cn in MeO chloride gives MeO-CH2CN. Therefore, the correct answer is B. Therefore, the correct answer is option B.